Have you ever wondered what the future of lunar exploration holds? Imagine astronauts walking on the moon once again, but this time, it's not just a visit, it's the beginning of humanity's long-term presence on our closest neighbor. What if the moon could become a launch pad for missions to Mars? In 2025, we're about to witness some of the most exciting lunar missions ever. From international collaborations to groundbreaking technology, the moon is set to become the center of space exploration. Are you ready to explore what's coming next? Let's dive in. NASA's Artemis program. The excitement surrounding NASA's Artemis program is palpable as we edge closer to a new chapter in lunar exploration. The Artemis mission is not just a return to the moon, it's a stepping stone for humanity's journey to Mars and beyond. The Artemis II mission, scheduled for 2026, will be the first crewed flight around the moon since Apollo 17, marking an incredible milestone. 4 astronauts will embark on this historic journey, orbiting the moon before returning to Earth. Imagine the thrill of seeing our Earth from space once again, just like Apollo astronauts did decades ago. But what makes Artemis III, set for 2027, even more exciting is its ambition to land astronauts near the lunar South Pole. This is no ordinary landing site. The South Pole is a treasure trove, believed to contain vast amounts of water ice. This ice could potentially fuel future missions and even support a sustainable lunar presence. For the first time in history, we'll be walking on an uncharted part of the moon. NASA's ambitious plans go beyond just visiting. They're focused on building a sustainable lunar presence with habitats, scientific outposts, and resource mining, all key for preparing us to explore the Red Planet. The Artemis program is set to revolutionize not just lunar exploration, but the entire future of space travel. With technology, innovation, and international collaboration on its side, Artemis is paving the way for a new era of space exploration. Get ready to be part of history in the making. China's Chang'e missions. China's Chang'e missions are pushing the boundaries of lunar exploration, and 2025 promises even greater strides. The Chang'e 6 mission, launching in 2025, will make history by returning lunar samples from the moon's far side, an area that has never been explored by humans. This mission will touch down in the moon's South Pole Aitken Basin, one of the largest and most ancient impact craters in the solar system. Scientists believe this region holds answers to the moon's earliest history and secrets about the formation of the solar system. The Chang'e 6 mission represents more than just a scientific venture, it's a step toward China's ambition to lead in space exploration and lunar development. But that's just the beginning. By bringing back lunar samples from an untouched region, China will help scientists around the world unlock secrets about the moon's composition and the presence of water ice, which could be used for fuel and other resources in future missions. China's growing space presence will enhance international collaboration, especially as it partners with other nations to share data and findings. The Chang'e program is not only about exploration, it's also about sustainability. As China looks to build on its achievements and create a permanent presence on the lunar surface, Chang'e 6 is poised to deepen our understanding of the moon and reshape the future of lunar exploration for generations to come. India's Chandrayaan missions. India's space agency ISRO has been making remarkable strides in lunar exploration, and the next chapter of this journey is incredibly exciting. Following the success of Chandrayaan-2, which placed a rover near the moon's south pole, India is setting its sights even higher with Chandrayaan-4, set to launch by 2027. The success of Chandrayaan-3 in 2023, which landed near the South Pole, made India only the 4th country in history to achieve a soft landing on the moon. This achievement has not only positioned India as a rising space power, but has also opened up incredible scientific opportunities. Chandrayaan-4 will be even more ambitious, with plans to return lunar samples to Earth. These samples will help us understand the moon's geological history and its potential to support future lunar missions. But there's more. ISRO's focus on the moon's south pole is crucial because this region contains water ice, one of the most valuable resources for sustainable space exploration. India's lunar missions are poised to contribute vital data on the moon's resources and how they can be used for future space exploration. As part of an international lunar science community, India is playing a pivotal role in unlocking the moon's secrets. The Chandrayaan missions are paving the way for India to not only contribute to lunar science, but to become an essential player in the exploration of our solar system. India's lunar ambitions are just beginning, and the next mission is sure to push the boundaries of what we know about Earth's closest neighbor. Commercial lunar landers. The future of lunar exploration isn't just about governments, it's also about private companies stepping up to the challenge. In 2025 we're going to see more private sector involvement than ever before, with commercial lunar landers like Intuitive Machines and Astrobotic leading the charge. These companies are not just launching payloads into space, they are taking humanity a step closer to creating a permanent lunar presence. Intuitive Machines' IM-2 mission, set to launch early in 2025, will land near the Shackleton crater, a region that holds clues about the moon's water ice deposits. This mission will open doors to the exploration of lunar resources that could one day be used for fuel, water, and life support on the moon. Astrobotic's Griffin 1 mission, scheduled for late 2025, is another milestone in private lunar exploration. This mission will deliver scientific payloads to the moon, including experiments and technologies that could be vital for establishing a sustainable lunar infrastructure. The rise of commercial companies in lunar exploration signals a new era, one where private enterprise plays a major role in space exploration. These companies are helping to drive innovation, reduce costs, and make space more accessible. In fact, many experts predict that commercial lunar landers will not only change how we explore the moon, but will also play a critical role in future Mars missions. The partnerships between private companies and space agencies are forging a path toward a future where lunar exploration isn't just for a select few but is a global effort. The possibilities are limitless, and the moon is just the beginning. International collaborations. As the race to the moon accelerates, international collaborations are becoming a crucial part of the lunar exploration landscape. These partnerships are not just about sharing the costs of missions, but about combining the expertise, technology, and resources of multiple nations to achieve something greater than any one country could accomplish on its own. In 2025, we will witness some of the most exciting joint lunar missions, with countries like India, Japan, and even the United States teaming up for groundbreaking research and exploration. One such collaboration is the Joint Lunar Polar Exploration Mission, which India and Japan are developing. This mission will focus on the lunar South Pole, an area that holds vast reserves of water ice, one of the most valuable resources for sustaining human presence on the moon. By joining forces, these nations will combine their scientific and technological capabilities, ensuring that the mission is as successful as possible. The data collected will be vital for understanding the moon's resources and creating a sustainable future for lunar exploration. These international partnerships are more than just about scientific discovery. They're about building a united front for the future of space exploration. As nations collaborate on the moon, they are also laying the groundwork for future cooperation on Mars, asteroids, and beyond. The exchange of knowledge, technology, and expertise ensures that all countries involved benefit, while the collective achievement of humanity is pushed further into the cosmos. The moon has always been a symbol of human curiosity and ambition, but now it's also a symbol of collaboration. And as we work together to uncover its secrets, we also work toward building a future where space exploration is a global endeavor. Future lunar infrastructure. The vision for the moon is rapidly transforming from short-term missions to long-term infrastructure. The Lunar Gateway, a project initiated by NASA, is set to play a pivotal role in this transformation. This space station, positioned in lunar orbit, will serve as a staging point for crewed missions to the moon and beyond. The Gateway will provide astronauts with a safe and reliable location to dock, refuel, and resupply before heading to the moon's surface. This infrastructure is crucial for creating a sustainable human presence on the moon, and will be key in our efforts to explore Mars and other parts of the solar system. But the Gateway is only one part of the bigger picture. To support long-term lunar exploration, there's a need for advanced technology that can harness the moon's resources. NASA, along with other space agencies, is developing systems to extract water from the moon's ice deposits and use it for fuel, oxygen, and even drinking water. This technology is vital for sustaining astronauts on extended missions. Additionally, research into building habitats using lunar soil is underway, as this will allow for the creation of permanent lunar bases that can support future generations of astronauts. These efforts are laying the foundation for a self-sustaining lunar outpost that doesn't rely on Earth's resources. The goal is not just to visit the moon, but to build a lasting presence that can support human life and serve as a launchpad for further space exploration. With the right technology, international collaboration, and a focus on sustainability, the moon will become humanity's stepping stone to the stars. As we lay the groundwork for this future, we're not just expanding our reach into space, we're securing humanity's place as a multi-planetary species. So there you have it. 2025 is shaping up to be an incredible year for lunar exploration. With groundbreaking missions, international partnerships, and cutting-edge technology, the moon is closer than ever to becoming humanity's next frontier. What do you think the future holds for lunar missions? Let us know in the comments. Don't forget to like, share, and subscribe to Space Facts for more exciting updates on space exploration. The cosmos is full of wonders, and we're here to uncover them together. Until next time, keep looking up. Have you ever wondered where everything came from? Like not just Earth or the stars, but space, time, and reality itself? What if I told you the entire universe was once smaller than a grain of sand? In today's video, we're diving deep into the ultimate origin story, the Big Bang. How did it happen? What came before it? And are we still feeling its effects today? Grab your curiosity because this journey will blow your mind. Ready to travel back 13.8 billion years? Let's explore the beginning of everything together. What was the Big Bang? Hey, have you ever looked up at the night sky and wondered, how did all this even begin? I mean, everything. The stars, the galaxies, the very space between them. It's mind-blowing to think that the entire universe once fit into something smaller than a pinhead. That's not just poetic, it's science. Scientists call it a singularity. No stars, no planets, no time, no space. Just infinite density and temperature packed into one unimaginable point. And then boom, about 13.8 billion years ago, the universe began. But here's the twist. The Big Bang wasn't an explosion in space. It was the sudden expansion of space itself. Space stretched, time ticked for the first time, and matter began to form. From nothing came everything. There wasn't some big kaboom with fireworks flying into empty darkness, because there was no outside to begin with. The Big Bang created space, time, energy, and all the rules that govern our reality today. It's like reality booted itself up from zero. And here's the real kicker. You, me, the device you're watching this on, we're all made of the same ancient energy that burst forth from that original moment. So next time someone asks where you're from, you can say, the Big Bang. It's not just science fiction, it's your origin story. The first moments. Alright, let's zoom in on those first few mind-melting moments after the Big Bang. And by moments, I mean we're talking less than a trillionth of a second. Imagine the universe going from microscopic to cosmic in the blink of an eye. That's called cosmic inflation. It's not just fast, it's ridiculously fast. We're talking faster than light expansion. In this phase, space itself stretched so rapidly that tiny quantum fluctuations, tiny ripples in the energy fabric, were stretched into the seeds of galaxies. No joke, those little wiggles eventually became us. During this period, the fundamental forces of nature began to separate: gravity, electromagnetism, and the nuclear forces. Think of it like the universe untangling its own rulebook while it was still being written. And even though it was blazingly hot, energy condensed into particles, the first building blocks of matter. We're talking quarks and electrons, not yet atoms, but the very idea of matter. It's wild to think that everything we see today, galaxies, black holes, pizza, memes, started from this chaotic, intense moment. Inflation not only made the universe big enough to evolve, but also smooth enough to become the calm cosmos we observe now. And the best part? We can still see the echoes of that inflation today. The afterglow is still out there, frozen in time, whispering the universe's birth story across the sky. Big Bang nucleosynthesis. So now that the universe has gone from a quantum seed to an expanding, fiery mess, what's next? It cools down just enough to start cooking, and I mean literally cooking elements. Around 3 minutes after the Big Bang, yeah, just 3, the temperature drops to about 1 billion degrees. That's when something magical happens. Nucleosynthesis. Protons and neutrons start teaming up, fusing together to form the very first atomic nuclei. Not full atoms just yet, but the cores. The recipe was simple, but it changed everything. Take a bunch of protons, stir in some neutrons, apply insane heat, and you get the universe's first ingredients. Hydrogen, helium, and a sprinkle of lithium. That's it. No gold, no oxygen, no iron. Just the basics. But these basic ingredients were like cosmic Lego bricks. They were the raw materials from which stars, galaxies, and life itself would one day form. Think about it. Every drop of water, every breath you take, every cell in your body is built on the foundation laid during those first few minutes of creation. And what's even cooler, the predicted ratios of these elements match exactly what we see in space today. That's how scientists know this theory is on the right track. The Big Bang wasn't just an origin story, it was the universe's first chemistry class. And you're the long-term result of its wild experiment. The universe's afterglow. Let's jump ahead to a universe that's about 380,000 years old. By cosmic standards, it's still just a baby, but something extraordinary is about to happen. Until now, the universe has been a swirling, chaotic plasma soup, so hot that light couldn't travel freely. Photons kept crashing into free electrons like bumper cars in a demolition derby. But suddenly, the universe cools just enough for electrons and nuclei to finally bond and form neutral atoms. And boom, light breaks free for the first time. That ancient light is still traveling across the cosmos today, and we call it the cosmic microwave background, or CMB. It's like the baby picture of the universe, faint, stretched-out radiation that tells us what the universe looked like when it was just a few 100,000 years old. And guess what? Scientists have captured it. It's not just theory, they've measured it with satellites like COBE, WMAP, and Planck. What they found was astonishing, a nearly perfect glow spread across the entire sky with tiny variations that hinted at future galaxies. So when you stare up at the night sky, just know you're bathing in ancient light. It's the literal afterglow of creation. The universe left us a message in its own light, and it's been whispering its story for almost 14 billion years. Kinda romantic, right? Evidence supporting the Big Bang theory. Okay, so all this Big Bang stuff sounds cool and cosmic, but let's be real. How do we actually know any of this happened? I mean, it's not like we were there with a camera 13.8 billion years ago, right? Well, this is where science flexes hard. The Big Bang theory isn't just a wild guess, it's backed by solid, observable evidence. First, up-galactic redshift. When we look at distant galaxies, their light is stretched, shifted toward the red end of the spectrum. Why? Because space itself is expanding, pushing galaxies apart. It's like raisins moving apart in rising dough. Second, remember the cosmic microwave background we just talked about, that faint glow? It's exactly what you'd expect if the universe started as a hot, dense fireball. Third, we have the elemental recipe. The universe's mix of hydrogen, helium, and lithium perfectly matches the predictions made by Big Bang nucleosynthesis. It's not just a lucky guess, it's precise. Scientists didn't just make this stuff up after seeing the results, they predicted it first, and the results matched. That's what makes it so compelling. The universe isn't keeping secrets, it's actually leaving breadcrumbs all over the place. And we've been smart and curious enough to follow them. That's why, today, the Big Bang theory is the most widely accepted explanation for the universe's origin. It's not just a theory, it's evidence-based storytelling written in starlight. Ongoing mysteries and the role of dark components. Now, before we all pat ourselves on the back, let's admit something. We don't have all the answers. Not even close. In fact, 95% of the universe is still a total mystery to us. Yeah, you heard that right. Everything we can see, stars, planets, people, pizza, that's just 5%. The rest, it's made up of dark matter and dark energy. Sounds like something out of Star Wars, but it's real. Dark matter doesn't emit light, doesn't absorb it, and we can't see it, but we can see its effects. It's like a ghost holding galaxies together, adding gravity where there shouldn't be enough. And then there's dark energy, the invisible force pushing the universe to expand faster and faster. Imagine driving a car that accelerates on its own and you can't find the gas pedal. That's our universe right now. These two dark components dominate the cosmos, but we barely understand them. It's humbling, isn't it? Even after decades of research, we're still staring into the dark, asking questions. And maybe that's the best part. The Big Bang doesn't just give us answers, it gives us better questions. It reminds us that curiosity is infinite, just like the universe. Expansion continues. So now we know how the universe began, but here's the final question. How will it end? Will the universe go out with a bang, a whimper, or something we can't even imagine yet? Let's talk about the possibilities. First, if dark energy keeps pushing everything apart, galaxies will drift so far away from each other that the night sky will go dark, literally. Stars will die out, matter will decay, and we'll be left with a cold, empty void. Scientists call this the Big Freeze or heat death. Not exactly cheerful, right? Another theory? The Big Rip, where expansion gets so intense that it tears galaxies, stars, planets, and even atoms apart, like the universe is being pulled apart at the seams. Then there's the Big Crunch, a sort of cosmic rewind. If gravity somehow wins over dark energy, the universe could collapse back into a singularity. Boom, back to square one. And hey, there's even the bounce theory, where the universe ends and begins in an endless cycle of bangs and crunches. We don't have the final answer yet, but we're watching the clues. Telescopes, satellites, simulations, they're all trying to read the universe's endgame. One thing's for sure, we're living in a cosmic story still being written, and isn't it wild that we're here right now, on this tiny blue dot, wondering how it all began, and how it might end? And just like that, we've traveled from the tiniest singularity to the vast cosmos we call home. The Big Bang isn't just science, it's our origin story, written in stars and stardust. If this blew your mind even a little, imagine what else the universe is hiding. Don't forget to hit that like button, subscribe, and ring the bell so you never miss a cosmic journey. Got questions? Drop them in the comments. I love hearing your thoughts. This is Space Facts, and the universe is just getting started. Until next time, keep looking up. In 1610, Galileo gazed through his telescope and unknowingly discovered a storm so colossal, it could engulf 3 Earths. That storm, the Great Red Spot on Jupiter, has raged for over 350 years. A hurricane older than modern civilization spinning endlessly across the face of a gas giant. Scientists have studied it for centuries, and still its secrets remain locked in swirling mystery. We don't know how it began. We don't know why it's red. We don't even know why it won't die, so if you hovered above it, would you feel wonder or dread? Let's dive into the storm. What is the Great Red Spot? You've probably seen photos of Jupiter, massive, striped, mysterious. But what if I told you one of the planet's most iconic features is actually a storm so large it could swallow Earth 2, maybe 3 times over? Yeah, that giant reddish oval isn't just a pretty swirl, it's chaos, controlled chaos. They call it the Great Red Spot, but that name doesn't even come close to capturing what's going on. This isn't your average storm. It's a swirling beast, an anticyclonic tempest that's been howling in Jupiter's atmosphere for at least 350 years, and likely much longer. Spinning with winds exceeding 430 kilometers per hour, it sits in the planet's southern hemisphere like a never-ending wound in the sky. Unlike storms on Earth which form and vanish in days or weeks, this one refuses to die. Scientists believe it's trapped between powerful jet streams that feed its fury, keeping it spinning like a cosmic blender. Now here's where it gets weirder. Jupiter doesn't even have a solid surface. So this storm isn't slamming into any ground to slow it down, it's floating. A monstrous, hovering hurricane, powered by Jupiter's turbulent atmosphere and fed by dynamics we still don't fully understand. Think about that. Earth's fiercest storms are toddlers compared to this ancient planetary giant. How big is it? Let's break scale for a second. Earth has hurricanes, sure. But they're barely pimples next to this. At its largest, the Great Red Spot measured over 40,000 kilometers wide. That's more than 3 Earths, side by side, spinning around inside a single storm system. It was the kind of storm that made even veteran astronomers shake their heads in disbelief. But here's the twist. It's shrinking. Yup, this legendary vortex has been getting smaller over the last century. Current estimates say it's about 12,000 kilometers across. Still massive, but a shadow of its former self. And it's not just shrinking, it's also changing shape. What was once a wide oval wound is slowly turning into a more circular form. No one knows exactly why. Could it be dying, evolving, or gearing up for something new? NASA's Hubble Space Telescope has been tracking it closely, and even that eye in the sky can't predict its fate. Every year brings new surprises, rips in its structure, blobs of gas breaking off, or sudden color shifts. It's like the storm is alive, rewriting its own story as we watch. So the next time you see a picture of Jupiter, remember, that red dot isn't just a dot, it's a mystery bigger than Earth, literally. Why is it red? Ever stared at Jupiter's Great Red Spot and thought, why that color? I mean, it's not just red, it's deep, rusty, bloody red, the kind of shade that feels ancient. And what's wild is, scientists aren't even fully sure why. The truth? We don't have a definitive answer. And that's part of what makes this storm so maddeningly fascinating. Some researchers believe that chemicals in Jupiter's upper atmosphere, like ammonia and acetylene, get blasted by ultraviolet light from the sun. That intense solar radiation could trigger chemical reactions, creating complex substances known as chromophores, which reflect red and orange hues. Basically, sunlight is cooking Jupiter's atmosphere like a chemical stew, and the Great Red Spot is what bubbles to the surface. But here's where it gets even more bizarre. Sometimes the color changes. Over the decades, astronomers have observed it appear lighter, darker, or more orange-toned. That suggests something dynamic is happening, either at the cloud tops or even deeper in Jupiter's chaotic atmosphere. One theory hints that we're not seeing the storm's real color at all, just a stained upper layer, like tinted glass hiding the real storm beneath. It's a mystery wrapped in science, cloaked in clouds. And the more instruments we point at it, from Hubble to Juno, the more questions arise. What if the Great Red Spot is trying to tell us something about Jupiter's chemistry that we've missed entirely? The color might be a clue, or it might be a cosmic red herring. How did it form? The craziest thing about the Great Red Spot, no one knows exactly how it began. Think about that. We've been staring at this storm since the 1600s, and its origin story is still shrouded in gas, chaos, and theory. Some scientists say it started when multiple smaller storms merged, like angry tempests colliding to become one massive superstorm. Others believe it emerged from the wild dynamics between Jupiter's fierce jet streams, which tore open a hole in the sky and gave birth to a monster. Jupiter's atmosphere is layered, fast, and unstable. It's a planet made of swirling gases rotating at breakneck speeds, with no solid surface to ground anything. So when a disturbance happens, it doesn't just fizzle, it spins, strengthens, and gets sucked into the rhythm of the planet itself. The Great Red Spot might have formed when one such disturbance just refused to die. Instead, it locked into a powerful zone between opposing winds like a spinning top caught in an endless tug of war, and the storm's anticyclonic nature, meaning it spins opposite the planet's rotation, makes it even more stable. Instead of fading out, it dug in, for centuries. Some even speculate that the storm could predate our telescopic observations, meaning it might have been there longer than modern science has existed. It's not just a storm, it's a survivor. Is it shrinking or changing? You wouldn't expect something this massive, this ancient, to change, but it is. In fact, the Great Red Spot is shrinking, and fast. Back in the 1800s it spanned more than 40,000 kilometers across. Today, just around 12,000 kilometers. That's like watching a continent-sized hurricane collapse down to the size of a country. And yet, despite this dramatic reduction, the storm is somehow holding on, refusing to disappear entirely. But size isn't the only thing shifting. The shape is changing too, becoming more rounded, less stretched. Even stranger, scientists have spotted chunks of the storm peeling off, forming smaller vortices that break away like sparks from a fire. Some experts call it storm flaking, while others think it's the red spot fighting to stabilize itself. Either way, it's like watching a giant creature shed its skin in slow motion. In 2019, observers saw a series of mysterious blades or extensions protruding from the storm's core, like arms reaching out before quickly pulling back. And while some predicted the storm's imminent death, data from the Juno spacecraft showed something shocking. Beneath the visible layers, the red spot is deeper than we thought, up to 300 kilometers into Jupiter's atmosphere. So while the top might look like it's fading, the roots, still powerful, still fierce. Maybe it's not dying, maybe it's evolving, adapting, or hiding its true power deeper inside where our instruments can barely reach. What lies beneath? What's happening beneath the swirling clouds of the Great Red Spot? While the storm itself is incredible to observe from above, scientists are just as curious about what's going on beneath the surface. Thanks to NASA's Juno spacecraft, which has been orbiting Jupiter since 2016, we now have some incredible data about the depth of the storm. For years, researchers believed that the Great Red Spot was only a feature of Jupiter's upper atmosphere, but Juno's data has revealed something more surprising. It turns out that the storm extends deep into the planet's atmosphere, up to 300 to 500 kilometers beneath the clouds. But what's really happening down there? That's still a bit of a mystery. The Great Red Spot's depth suggests that it's not just a surface-level phenomenon, it's a massive atmospheric feature that penetrates deep into Jupiter's layers. Some scientists think that the storm's depth might be related to the planet's internal heat, which could play a role in powering the storm. Jupiter's heat source is still not fully understood, but it seems that the planet's intense internal energy helps sustain the storm's immense size and strength, Additionally, this deep penetration could be affecting the dynamics of the entire atmosphere, creating a feedback loop that keeps the storm going. What else might lie beneath? Jupiter's atmospheric layers are still largely unexplored, and the Great Red Spot may hold clues to understanding the planet's deeper atmospheric and internal processes. As Juno continues to send back more data, scientists hope to gain a clearer picture of the forces that drive the Great Red Spot and the broader atmospheric dynamics of Jupiter. The more we learn about what's happening below the surface, the better we'll understand not only Jupiter's weather, but also how other gas giants in our solar system, and possibly even exoplanets, might behave. What are scientists discovering now? When NASA's Juno spacecraft arrived at Jupiter, it didn't just snap pretty photos. It pulled back the curtain. What it revealed beneath the Great Red Spot left scientists stunned. This isn't just a surface storm, it plunges hundreds of kilometers deep, swirling through Jupiter's layers like a spinning skyscraper of wind. Think about that. Our storms float in the sky. Jupiter's storms dig into the planet itself. Juno detected gravitational anomalies as it flew over the red spot, indicating mass and density variations deep below the clouds. It's as if the storm has a skeleton, a complex internal structure that anchors it in place. And then, there are the atmospheric waves, strange ripples of energy moving outward from the storm like it's broadcasting its presence across the planet. No one expected to find those. Even more shocking, instruments have picked up heat signatures from deep inside, suggesting something energetic is brewing beneath the visible layers. Combine that with data from the James Webb Space Telescope, and you get a picture that's more alien than we ever imagined. Layers of gas rotating at different speeds, chemical reactions we can't fully simulate on Earth, and signs that the storm's power source may come from below, not just the sun. What's going on inside Jupiter might hold answers to how gas giants work, not just in our solar system but in distant exoplanets too. The Great Red Spot isn't just a curiosity anymore, it's a lab, a puzzle, and we're only beginning to crack it open. How does the Great Red Spot affect Jupiter's weather? Jupiter's Great Red Spot doesn't just sit there looking menacing, it plays a key role in the planet's complex weather system. While Earth's weather is driven by the sun, Jupiter's immense size and distance from our star create a very different dynamic. The Great Red Spot is one of the driving forces behind the planet's atmospheric movements, contributing to powerful jet streams and storm systems across the gas giant. But how does this massive storm influence the weather on a planet without a solid surface? The Great Red Spot interacts with Jupiter's fast-moving jet streams, creating areas of low and high pressure. These powerful wind patterns affect everything from the planet's cloud formations to the movement of its other massive storms. Some researchers believe that the storm's presence might even help stabilize Jupiter's atmosphere, keeping it in a constant state of flux, and preventing other, smaller storms from growing too powerful. Even though the Great Red Spot might be shrinking, its influence is still widespread. As scientists continue to study the planet's atmosphere, they are learning that this storm may be an integral part of how Jupiter's weather patterns maintain their unique characteristics. It's more than just a visual phenomenon. It's a crucial force that helps shape the very nature of Jupiter's chaotic skies. What we learn about the red spot could help us understand not only Jupiter but also how storms form on other gas giants, and even exoplanets we've yet to discover. Thanks for exploring the mystery of Jupiter's Great Red Spot with us. Space isn't just out there, it's a mirror reflecting how little we truly know. Every swirling storm, every unexplained force reminds us that the universe is alive with secrets still waiting to be discovered. What do you think lies beneath that crimson vortex? Could it be more than just a storm? We'd love to hear your thoughts in the comments below, and if you love discovering the secret of the universe, don't forget to like, subscribe to Space Facts and hit the bell icon for more adventures. In 1610, Galileo saw Saturn, but he didn't understand it. His telescope showed strange ears, not knowing they were icy rings that would puzzle humanity for centuries. Today we know those rings are vast, delicate, and possibly vanishing before our eyes, a cosmic masterpiece, fading in silence. Scientists think a lost moon or a celestial collision may have created them. But we still ask, why Saturn? Why not the others? If you stood beneath those radiant bands, would you feel awe or sorrow for what's slipping away? Let's explore the truth behind Saturn's vanishing crown. The enigmatic beauty of Saturn's rings. If you were standing on the surface of one of Saturn's moons, you'd see something that almost doesn't look real. Towering arcs of shimmering ice stretching across the sky like a celestial ribbon. For centuries, this sight has mystified stargazers and astronomers alike. Saturn's rings aren't just decoration, they're clues. Clues to a violent cosmic past, to the invisible forces that shape our universe, and to the kind of beauty that only space can sculpt. But what's wild is that when Galileo Galilei first saw them in 1610, he had no idea what he was looking at. His telescope was primitive, and to him, Saturn looked like it had ears. It wasn't until decades later that scientists realized these weren't ears or wings, but rings. Massive, flat rings made of something far more fragile than rock, ice. Not one single ring, but thousands of tightly packed ringlets spanning hundreds of thousands of kilometers. They're wide enough to stretch nearly the distance from Earth to the moon, but they're razor thin, barely 10 to 30 meters thick in most places. So, why do they exist at all? Why Saturn and not Jupiter or Uranus in the same way? That's where things get fascinating. Let's break it down. What Saturn's rings are really made of. Most people think Saturn's rings are solid, like a giant hula hoop floating in space, but that couldn't be further from the truth. These rings are made of billions, yes, billions of tiny particles, each orbiting Saturn independently. They range from microscopic dust grains to house-sized boulders, and they're mostly composed of water ice, which explains why they reflect sunlight so brilliantly. But here's the twist: they aren't pure ice. Hidden among the icy debris are specks of rocky material and organic compounds. That's right, some of the same carbon-rich molecules that may have played a role in forming life on Earth are found in Saturn's rings. Scientists think the difference in ring color, some being brighter, others darker, might be due to the varying amounts of this dusty contamination. And while they look smooth from afar, the rings are more like a cosmic traffic jam up close. These particles constantly collide, clump together, and break apart again. It's chaos, but organized chaos ruled by gravity. Every motion, every gap between rings is shaped by Saturn's moons tugging on the particles like invisible hands sculpting art. And that chaos may hold the key to how the rings even got there in the first place. How did Saturn's rings actually form? A moon torn apart. That's one of the most widely accepted theories behind the formation of Saturn's rings. Sounds brutal, right? And it was. Scientists believe that long ago, Saturn may have had a large icy moon that drifted too close, within the planet's Roche limit, a point where Saturn's tidal forces became stronger than the moon's own gravity. The result? The moon was literally shredded into pieces. But that's just one version of the story. Another theory is even more chaotic. What if two moons collided at high speed, turning into a spray of debris that spread around Saturn like a slow-motion explosion in space? Over time, gravity helped those icy fragments settle into the thin, structured rings we see today. This theory is supported by how flat and disc-like the rings are, just like the aftermath of a spinning cosmic smash-up. Some scientists even think these rings could be the remnants of material that never formed into a moon at all, a frozen ghost moon that failed to become whole billions of years ago. But here's the catch. No matter the theory, one thing remains clear: the rings are a result of destruction. Something had to break, rip, or explode for them to exist. Saturn's beauty is born out of cosmic violence, and that makes it even more incredible. Are Saturn's rings old or surprisingly young? You might assume Saturn's rings have been around forever. After all, the planet itself is over 4.5 billion years old. But what if I told you that the rings might be younger than the dinosaurs? That's right. Some scientists now believe that Saturn's rings may have formed as recently as 100 million years ago, when T-Rex roamed Earth. That's practically yesterday on a cosmic timeline. How could something so massive be so young? It all comes down to their brightness. The rings are incredibly reflective, meaning they haven't been exposed to space dust and debris long enough to darken over billions of years. On the flip side, there's a competing theory that says we've just gotten lucky. Maybe the rings really are ancient, but their icy particles constantly recycle themselves, colliding, breaking down, and reforming, keeping them looking fresh and clean despite their age. Cassini's mission tried to settle the debate, measuring how much ring material is falling into Saturn's atmosphere. The data leaned toward a shorter lifespan, meaning we may be living in a rare moment in time when Saturn is dressed in her finest. Either way, the rings are temporary. Whether they're ancient or newborn, they won't last forever. We're witnessing a fleeting masterpiece, and most of the universe won't even get the chance. What NASA's Cassini mission uncovered about the rings. One spacecraft got closer to Saturn's rings than anything in human history, and it changed everything. NASA's Cassini mission, launched in 1997, didn't just orbit Saturn. It danced through its rings, it flew between them, and what it saw was astonishing. Cassini revealed that the rings aren't uniform at all. They're full of waves, literal ripples caused by gravitational tugs from Saturn's dozens of moons. These waves aren't just beautiful, they act like seismic maps. They help scientists understand Saturn's interior structure, the same way earthquakes help us understand Earth's core. Wild, right? And then there were the propellers, tiny gaps carved by moonlets no bigger than a city block. These baby moons move like little shepherds pulling and pushing ring particles, leaving trails behind like ships through ice. It's a whole ecosystem of motion. Collisions, orbits, spirals, all governed by gravitational forces we can't see but Cassini could feel. What stunned scientists most was the sheer level of detail. They found sharp edges, sudden gaps, and braided structures like strands of hair woven by the cosmos itself. Saturn's rings aren't just pretty, they're alive with motion. Cassini didn't just observe them, it revealed a complex, dynamic system still evolving before our eyes. Will Saturn's rings eventually disappear? They look eternal, but Saturn's rings are fading. Right now, as you read this, those magnificent ice particles are falling, bit by bit, into the planet they orbit. It's called ring rain, and it's caused by Saturn's magnetic field, pulling charged particles from the rings down into its atmosphere. NASA estimates that each second, tons of ring material is being lost forever. Think about that, a structure hundreds of thousands of kilometers wide, vanishing grain by grain like sand in an hourglass. Scientists now believe the rings could be gone in as little as 100 to 300 million years. In cosmic time, that's a blink. And that means we are alive at one of the rare moments in history when Saturn even has rings this bright and massive. Most other planets don't get this kind of spotlight, we just happen to be born at the perfect time to see it. The rings are like fireworks on a galactic scale, stunning, fleeting, and impossible to ignore. One day future civilizations may only see Saturn as a plain gas giant. No icy crown, no shimmering halo, just a memory left in textbooks and telescopes. And that makes every glance at Saturn now feel a little more sacred. The role of Saturn's moons in shaping the rings. Saturn's moons play an incredibly crucial role in the creation, maintenance, and structure of its rings. These moons act as both sculptors and guardians of the rings, exerting gravitational forces that shape the particles within them. Saturn has over 80 moons, but many of them are especially important for the delicate dance of the planet's rings. Some moons, like Pan and Atlas, are small yet vital to the structure of Saturn's rings. They create gaps, or propellers, within the ring material, where the gravitational pull of the moon pushes particles into a tightly packed structure, while leaving a gap in its wake. These gaps resemble the paths left behind by ships moving through ice, and they help maintain the ring's shape and distribution. The effect is not just visual, but also vital for the dynamic behavior of the ring system. On the other hand, moons like Mimas, Enceladus, and Dione have more indirect roles. They interact with the rings by generating gravitational waves, small fluctuations that ripple through the material, organizing it into neat, concentric bands. These waves influence the ring particles' movement and maintain their organized chaos. Through their gravitational interactions, Saturn's moons help to prevent the particles from scattering away into space, ensuring the rings stay intact over millions of years. Interestingly, the material in Saturn's rings is not static, it's in constant motion, constantly being tugged by the moons. This interaction is a prime example of how moons and rings coexist in a delicate balance, with each influencing the other. Without these moons, the rings would likely lack the fine structure and order they currently display. Rather than a simple floating collection of ice, Saturn's rings are a complex, gravitationally controlled system that relies heavily on the nearby moons to sustain its beauty and form. Thanks for joining me on this incredible journey through Saturn's mysterious rings. From icy debris to shattered moons, the secrets they hold are as vast as space itself. There's still so much we don't know, and that's what makes it thrilling. Every new discovery brings us one step closer to understanding the universe we call home. So, what do you think created Saturn's rings? Drop your thoughts in the comments below. Let's start a cosmic conversation. And if you love discovering the secret of the universe, don't forget to subscribe to Space Facts and hit the bell icon for more adventures.